Hello and welcome to the show. I'm Martin Willis, your host, and I'm really excited about this evening's show. We have, I guess, what you would call sort of a sciencey show. And so if you like physics, you like astronomy, and you like UFOs, you're in for a treat. I met this gentleman through the SCU, which is the Scientific Coalition for UAP Studies. If you're new to this topic, UAP, UFO, kind of interchangeable. Well, I'll be welcoming in just a minute Professor Matthew Szydagis. And I have to caution everyone out there that I'm not a scientist. I'm not an astronomer or a physicist. So I am going to be asking probably some layman questions. I do contemplate these type of things a bit here and there. So hopefully there'll be some good questions, but I can guarantee you this, it's going to be an interesting evening for sure. So also, if you look in the show notes or you look below YouTube, you will see that there is a link to a slideshow of the things that Matthew is going to be talking about. Also, I do want to say to everyone, I don't want to sound like a teaser out there, but I think there's something that's going to be coming out fairly soon. I want to tell you to keep your eyes open in the UFO world. I don't have the details. I'm sorry. If I did, I would definitely share them with you. But I can tell you whatever is going to be happening is going to be noteworthy. Some people are speculating it has to do with the Wilson leak documents. I've talked about that a number of times. I don't, it might have something to do with some part of it, but I don't, I personally don't buy that story. But you know what? If I'm wrong, I will just say, hey, look, everyone, I was wrong. So anyway, just keep your eyes out. Something's happening. I do want to thank everyone who listens to the show and also everyone behind the scenes. We have Peggy helping us out on Facebook, and that is facebook.com/podcast UFO. And by the way, we're doing our very first simulcast over there. That might catch on. I don't know if there's a lot of people watching it over there or not, but that may catch on over there. So that is just one other way you can watch the show. We also have Bill Skywatcher over at KGRA Radio. I want to thank him and other people that help out in countless ways. And if you support the show, I want to thank you very much. And anyone can do that. The Patreon link is over at our website, podcastufo.com. And while you're there, check out the latest blog by Charles Lear. It's called UFOs over Finland. And he really goes into some great detail on all these blogs. And this one is extra special, really good. So I have a few paintings that I actually sold, the Winter Triangle. And for those of you on YouTube, you're going to hear my commercial. It might be better than silence. I don't know. But anyway, during the commercial break at the top of the hour, I have another art commercial for you. But anyone can check out martinwillisart.com. And there's a special link below, kind of a secret link in the show notes and also down below YouTube. That'll get you just to the UFO paintings. Remember, the code UFO gets you 50% off at checkout. I want to work out a deal. So anyway, you can always contact me at martin@podcastufo.com. So let's see about our guest, Professor Matthew Szydagis, and I'm trying to say his name right. He received a Ph.D. from the University of Chicago. He is now an assistant professor at the University of Albany, studying experimental particle astrophysics. Wow. In particular, the direct detection of dark matter, WIMPs, WIMPs, weekly. He'll go over all that stuff. And I don't want to get too carried away in his background because he's going to be talking about it, I'm sure. But he's another one of these scientists who got into the whole idea of the UFO topic by science fiction, Star Trek, and stuff like that. And how many of this has happened to many, many, many people I've talked to over the years. So I think it's really great. And welcome to the show, Matthew. Can you hear me, Matthew?
I can hear you. It's great to be here. Thanks for inviting me.
Yeah. I was really loved your talk over at the SCU. It was just fantastic. And I kind of gave a little bit of your background, but So right away, science fiction got you hooked on the science topic, and you've done quite an amazing job all the way over to dark matter and a lot more. So you want to talk about your background and what how young did you think you were going to be getting into this?
That's a great question. Yeah, it's very rare, but I actually knew what I wanted to do at the age of 5.
Wow.
And it all started with a book called What's Up There, a children's astronomy book. That's how it all started.
Wow.
And since age 5 to 10, 15, I would change my mind about what type of scientist I wanted to be: physicist, astronomer, astrophysicist, right? But I never wavered from knowing I was going to be a scientist, which I think is rare, right? People go through doctor, lawyer, keep changing your mind.
Yeah.
But I already knew all along through high school, I'm like, I'm going to major in physics in college. And the University of Chicago sat down with my advisor. We're talking. I'm like, no, there's no discussing options here. I'm a physics major. I flipped through the course catalog, and here are the courses I'm taking for the next 4 years. So can you take care of that? So she was like, whoa. So I was set. Like I really knew that's what I wanted to do. That book started it, but what deepened things was Star Trek. Actually, Star Trek: The Next Generation, because as you can see, probably I'm a little too young for the original series, but Next Gen came out when I was in preschool or kindergarten, that age. And I watched Next Generation season 1 through 7. And then I watched Star Trek Voyager in junior high and high school. And I felt it was so captivating, not just the science, but also a future where humanity has their problems behind them and work together peacefully.
Wow. I've talked about this before. I had an astrophysicist on. He was a visiting scientist at NASA, and he said, "Now I'm not probably quoting this completely accurately, but he said something along the lines that he and his colleagues agreed on the fact that if a civilization can get through the bottleneck of technology without blowing themselves up, that they will be exploring the stars." And I wondered what you thought about that comment.
Yeah, I think that we just have to look at our own example of humanity to see that. We see in recent months how many problems we still have. We still have, we have racism alive and well in the 21st century, right?
Yeah.
In the year 2020 is mind-boggling. So I do think that's been echoed. Similar sentiments have been echoed by both scientists as well as like science fiction authors, for example, for decades. And I think that is very true, that we have to get past our own hatreds, divisions, and conflicts as a race before we would be able to really achieve interstellar travel. And that would probably be true of any sentient, intelligent race that could potentially be out there.
Yeah. One of the things I think I see a lot out there, and when it comes to, and I want to say it's more on the skeptic side, and I know you're a healthy skeptic, of course, but I hear a lot of skeptics say, and think of travel, the possibility of travel from another solar system, which is mind-boggling. I know the distances are just so vast, but they think that they know all there is to know about the physics on travel and how things get here, and they say it's just plain impossible. And I heard you say something like, we know about 5% of the universe. Well, do you think we also know a very minuscule amount about physics, that there is so much more to learn?
That's a good question. I actually have many of my colleagues will disagree with me on this. So you have to know, right? Of course, this is my personal opinion, but I would not go so extreme as to say that we know minuscule, because if it was minuscule, the computer and technology we're using right now wouldn't work. So it's getting harder to be wrong. So what I mean by that is it was easier centuries ago, before they had telescopes and microscopes and computers. I'm not saying there isn't a lot more discovered. There obviously is. I'm looking for dark matter. There's also dark energy, these unknown portions of the universe. And what I'm trying to say is that what's left to discover, even if it's a great deal, will not erase what we currently know.
Right.
Because basically, so we should not think of the way I tell my students is that we don't have the same kind of paradigm shifts as we had hundreds of years ago. There's still plenty to learn, but it's not going to be like tomorrow we learn Einstein is wrong. For example, crackpots always say, oh, Einstein was wrong because X, Y, Z. It's too late for that. It's too late for that because your GPS wouldn't work without relativity, etc. Like, no, it's impossible. Impossible, period. Einstein and Newton to be wrong. What they are were incomplete. Our knowledge is absolutely incomplete. There's a difference between incomplete and wrong. So it's possible we know only a minuscule amount. That's possible. But of that minuscule amount, I think we do know it well. But unfortunately, sometimes that does lead to arrogance. We sometimes mistake knowing the minuscule amount we know very well. We mistake that for knowing the whole pie very well.
Right. I get exactly what you're saying. Now, so I'm going to be asking, like I mentioned earlier, a lot of questions. And of course, we are going to be talking about, how UFOs tie into all of this, but I just feel like I have so many questions, and also relating to dark matter as well. But I want to start out at the beginning of the beginning, which is the Big Bang. And do you, now I know a lot of scientists, they don't like to theorize about certain things, but do you think, I'm going to ask it this way, do you think it's possible that some part of the Big Bang could be incorrect of the theory that's out, the leading theory?
Well, it depends. It depends what you mean by incorrect. So we have to break it down in the following way. There is incontrovertible mountains of evidence that our universe had a finite beginning in time. So for example, the steady state theory that the universe is eternal is extremely dead. I think there are two more proponents left in their 80s or something, but they may have passed away. And that's because we've made so many discoveries in astronomy, like the cosmic microwave background radiation, which was a prediction of the Big Bang Theory. So the Big Bang Theory at this point cannot be wrong, in the sense that there's mountains of evidence. What can be wrong is the details. So we still haven't found direct evidence, for example, of inflation, which is the accelerated expansion of the universe after the Big Bang. We don't have direct evidence of that. So it depends what you mean by the Big Bang Theory. The most generic version of it that you can say in one sentence is that the universe had a finite beginning in time is extremely unlikely to be wrong. But the details, there are all kinds of details we can layer in, like what actually happens in the first few fractions of a second, and things like that. So the details absolutely that we have right now can be incorrect. We need to take more data. We're taking astronomical, cosmological data, but it would be, there's no 100% in science, but I would say it's very close to 100% that the universe had a beginning in time. Our best current estimate of the age is 13.8 billion years. It had a finite beginning in time, but the details, we're very far from having all of the details of that.
Sure. And so if this began 13.8 billion years ago, do people or scientists speculate that there was time before that, or did time start there? And if there was no time, what could have been before that, or is that time?
So this is one of those infamous questions. The question of before the Big Bang just doesn't make sense. We may never know the answer, not in a reliable, scientifically verifiable fashion. There are those like Roger Penrose, very famous physicist, who are speculating about, what could have happened, quote unquote, before the Big Bang, the idea that there's maybe a cyclical or oscillating cosmology. But I really very much like to stay away from that kind of thing, because in my opinion, even if there is an answer, it may be unknowable to us.
I see.
We may not be able to penetrate. We may not be able to ever, no matter what technology or ideas are invented. It may be something we will only be able to speculate about, but that we may not be able to get concrete data on. So I like staying away from questions of before the Big Bang.
Yeah, and you made a very good point. We may not understand, even if it was explained to us. It still may not. It's possible it may not make any sense. Now, I remember Carl Sagan had a saying, and I can't remember exactly how it goes, and I certainly had time to look it up, but I didn't. But he said something like, if there was never a supernova, you could never have the apple pie come out of the oven, or something along those lines. And along those lines, if there was never a supernova, would we have life?
No, that's an excellent point. You bring up Sagan's point. It's because in the Big Bang is only capable of making the lightest elements. You need the universe to grow and evolve and form stars. And then those stars basically cook up the heavier elements. And then supernova explosions, which are only we're learning are only part of the story. There's also neutron star collisions and other types of stellar phenomena that generate the heavier elements. So the Big Bang only generates hydrogen, helium, smattering of lithium and the lighter elements. To breed the heavier elements, you need stellar furnaces. You need the cores of stars. You need nuclear fusion. You need stars exploding, stars colliding in order to produce all those heavier elements, including carbon, nitrogen, oxygen, the ones that are in, sugar, salt, right? Not salt, I'm sorry, that's NaCl, but sugar and fats, proteins, all organic molecules.
Well, and along those lines, if say there was a solar system that developed very early, and it had one of the stars that lasts for billions and billions and billions of years. Mm-hmm. I know there is one type of star that does that at least. So they've never had a supernova in that part of their neighborhood. Does that mean that they are to remain lifeless?
No, because over billions of years, very slowly, of course, nowhere near the speed of light, but slowly, the supernova remnants, the gas and dust disperses. So when you said nearby, they had no supernova nearby. That's a very relative term, because nearby could mean, many light years. So I don't think that's the case, because you have to think about the fact that over billions of years, you have, supernova explosions, neutron star mergers, collisions that are seeding the interstellar medium.
Right. We have a question that just popped up on there. Did gold exist? This is from the chat room. Did gold exist as a gas back then?
Initially, I would say probably yes, or as a plasma even within stars. I can't say with complete certainty because I'm not a stellar astronomer. And remember that. So scientists are we have very highly specialized areas. So I want to be careful that I don't say something wrong if it's outside of my area. But I think that it would be more correct even to say not just as a gas, but originally as like individual atoms. And before that as individual nuclei without electrons around them. So it goes even deeper than that, further back in time.
Okay. So if we could travel to, say the universe is expanding, and we could actually travel to the very end of, when it began, what's there? What could be there? I mean, I can't picture a wall. I mean, how does the universe end? Not end in a way of, dying or anything like that. But
you mean physically, spatially? Physically, yeah. The universe is probably infinite. There is no end or wall or border. You said there's no edge. It just keeps going forever. If it's positively curved, then what could happen is that if you went forever in one direction, or for a long time one direction, you would come back where you started. You would circumnavigate the universe. So
Kind
the
of like
universe,
outside of a balloon.
exactly. Yeah. So the balloon analogy is often used in astronomy. I don't like it because it's only positive curvature that it shows. A better analogy I like to use with my students that is not mine. I found it online is the raisin bread. So imagine that the universe is an infinite raisin bread. Every raisin is a cluster of galaxies, and as the bread rises with the yeast, there's more space between the raisins, but there's no edge to the raisin bread. Goes to infinity in XYZ length, width, and height. So regardless of the shape of the universe, whether it's positively curved or flat or negatively curved, there's very likely no edge or wall. And so you should not picture, it's very tempting. So you should not picture the universe as a ball that's expanding. That analogy only works if you look at the surface of the balloon. In the balloon analogy, the central volume of the balloon doesn't exist. And it's a common mistake. You cannot think of the universe as a ball that just keeps expanding. There's nothing outside.
Yeah. Okay. I get that. Yeah. I'm going back for just a second to the Big Bang, and then I'm going to move on to dark matter. But going back to the Big Bang, how can someone actually picture something coming from nothing? I mean, that's basically what the Big Bang is. I mean, that's just unfathomable. Does that go along with something we just can't understand as well?
Yeah, this is where, like I said, we're hitting up, on our border of our understanding. But many physicists do not accept that. So, for example, the late Stephen Hawking did try to find a way around something from nothing. But in my opinion, again, this is not going to be the majority opinion of my colleagues, but the way I like to look at it is, there are philosophers have something like 9, I think I saw, or maybe it's more than that, probably a dozen definitions of nothing. So it really depends what you mean by nothing, because I think something from nothing is a little extreme, because one possibility is to look at it the following way, is that the laws of physics are always there. They're eternal in some way. And so you could have the Big Bang come as what you might consider as from nothing, from void, not as opposed to vacuum, which is far from nothing, has particles in it. And so I think that that really depends on your definition of nothing, not because there's so many different levels of nothing, right? Nothing is a very loaded word, like the word conscious, or the word, or it's a very loaded word that a philosopher versus a scientist have extremely different definitions of.
I think I was going to ask, and I have some dark matter questions, because I know it's just one of those things that we don't understand. But if you would please tell the listener audience of what we know as far as the matter that's out there and the percentages, and I know dark energy is something like 76% or something of. But anyway, if you don't mind just going into that.
Sure. So we have what's called the standard cosmological model. Is it perfect? No. But we are sure of the basics of it because of many independent data sets, many independent astronomical measurements that come together. And according to putting all of our best astronomical, astrophysical, and cosmological measurements together, we get an estimate of that 5% of the universe is atomic matter, that makes up you and me. And then 25% is this dark matter, and 70% is dark energy. Sorry, I made a mistake. That doesn't add up to 100%. So it's about, no, that was right, because 70, not 75, 70% dark energy, approximately like 69 point something. So how do we know that comes from? So these are labels for our ignorance. So the dark matter is a label. It means it's a form of matter that interacts primarily gravitationally, or perhaps only gravitationally, but at least primarily gravitationally. It doesn't have electromagnetic and nuclear forces like ordinary matter. And dark energy we know even less about. All we know is that there's something within the energy density of the universe that has an anti-gravity-like effect that is causing the expansion rate to accelerate. We don't know if it's particle or a field or energy, what the heck it is. Dark matter, we know a little bit more. We still know very, very little because we have not obtained direct detection of it. But what we do know is that at this point, with the amount of evidence we have, that it's very unlikely that, oh, it's just a mistake and most of the universe is just ordinary matter we see and we're just misunderstanding gravity. That's not, that's getting increasingly unlikely the more measurements we take. The more measurements, the more observations we make in astronomy, even though we still don't have conclusive detection from particle physics. In astronomy, we have a lot of what you could call indirect or observational evidence that there's matter out there, but it's unseen. It produces gravity, but it doesn't interact through the other forces that ordinary matter does.
Wow, that is so confusing. First, I want to just give a quick little shout out to a friend of mine over in Vienna. Hung out with him when I was over there. Eduardo, good to see you in the chat room. As far as now, you just made a point about not interacting, and that just kind of threw the wrench into a couple things I was going to say. But do you think it's possible that now I know nothing about any of this really to speak of, but do you think it's possible that, since astronomy is basically by observation, that it's possible that there's a spectra that we're unaware of that dark matter is in? Is that a real layman's question?
Well, so it could be, there could be an entire dark sector of particles that have their own self-interactions as well as interactions with ordinary matter, rare ones, but still have some interaction with ordinary matter other than gravity. So there are models out there that are called dark sector models, and I like them a lot because I think that it's not, I don't like the idea that like, oh, dark matter, it's probably one thing, because that's the easiest thing to say. I think it's more likely there's an entire rich sector that we're unaware of, which if I understood you correctly, which I think addresses your question.
Yes. And then this other thing I started thinking about, I started thinking, which is always dangerous, but about the atomic, what's it called? The atomic spacing, or I think it's called, or inner spacing, something like that. I understand like when a black hole occurs or down to a neutron star, like everything is compressed. And I think I saw somewhere where if they took all the space from the atoms of a human, it'd fit on a head of a pin, something like that. It's really quite amazing. And I started to wonder if, dark matter may not be a black hole, but somewhat compressed, atoms in some type of form along the way, that we're just unaware of that type of matter. I know I'm really reaching for straws, but do you understand where I'm going?
I think so, yeah. No, but I should clarify, dark matter is not necessarily black holes. They might have nothing to do with each other. Yeah.
Yeah. No,
but dark matter is all around us. So I think what you're getting at is the standard idea of dark matter. It's everywhere. It's right now. It's all around us. It's passing through us. It's just not interacting very often. We already have a particle like that. It doesn't fit the bill to explain dark matter, but there's the neutrino. There are, I forget how many trillions in a thumbnail. I should know it's a huge number. You're constantly bathed in neutrinos right now for example, from the sun, since neutrinos are a byproduct of nuclear fusion reactions. And so dark matter shouldn't be any more unusual than particles we already know and love, like the neutrino. We're just bathed in a sea of it harmlessly all the time right now. There's a great many probably of dark matter particles passing through you and me doing nothing at the moment even. So I hope, I'm not positive if that addressed your point. Well,
it was kind of a strange point anyway. But if let me also put this scenario past you too. We have matter and antimatter. Could there possibly be any correlation between matter and dark energy and dark matter and antimatter and dark energy?
Yeah, actually, yeah, that's a great question. So one of the greatest mysteries in physics is why we exist at all, because the Big Bang should have made equal amounts of matter and antimatter. But it didn't. It made a tiny little bit, something like 1 part in a billion extra matter. So when matter and antimatter annihilated into energy, the universe wasn't completely erased into energy, from matter into completely energy, but matter was left over, and that tiny leftover then became all the stars and galaxies. It is a great mystery in physics, and actually the neutrinos I mentioned are one of the ways we're probing that mystery. We're trying to understand differences between neutrinos and antineutrinos. Are they the same particle? Are they not? And so that's a big mystery. And kind of a second mystery, which may or may not be related, is why is the ratio, so this is one ratio, I just said matter and antimatter, so much more matter, by a huge a tiny factor. There was almost equal amounts of matter and antimatter born in the Big Bang. But then another mystery is, why is dark matter to ordinary matter approximately 5-1? Then where does that come from? And so there are these questions of ratios, of where do those ratios of different forms of matter come from, and are they related? Possibly. I know there is work in this area by theoretical physicists trying to relate these ratios between matter and antimatter, dark matter and matter. But to be clear, dark matter would also have anti-dark matter. So one of the ways we look for dark matter, actually, not the way I do, which is called direct detection, but another method which is in astronomy called indirect detection, looks for matter, dark matter meeting anti-dark matter, boom, annihilating into energy, and that energy converts into particles we know and love, gamma rays, neutrinos. So we look for those in astronomy. And so there may be matter, dark matter and anti-dark matter, just like there is with regular matter.
Wow. And I'm sure you've looked into the topic of the multiverse, and a lot of times people trying to explain away, dark matter in that way. What are your thoughts on that? The brain and all that. Yeah.
So we have to separate. There are two ideas, and science fiction just gets mixed up all the time. There's this extra dimensions and multiple universes are two completely different things. Star Trek mixes this up. Teenage Mutant Ninja Turtles mixes this up. So the brain idea, that's not exactly the same thing as a multiverse. That's just saying that there's an extra direction in which to move that we cannot perceive. So imagine we all lived in Flatland, right? That classic story. There would be no word in our language for up or down. So the idea behind extra dimensions is that perhaps, for example, dark matter is ordinary matter, but it's in an extra dimension. This is called the Randall-Sundrum model by famous physicist Lisa Randall and Sundrum. So this is one possibility. I don't like it because if it's right, that means we'll never find dark matter now with the techniques I'm using. So, but it is a valid idea, a suggestion, but that's not related to the multiverse. The multiverse is the idea that you have multiple completely separate universes, each with its own set of dimensions, length, width, and height, and what else. But those two, like parallel dimension and parallel universe, get very badly conflated. I see this on a regular basis. So we have to separate those two. They're both extremely interesting ideas in science fiction and in real science, but we should try to keep them separate.
Yeah, I did a pretty good job of mixing them up there.
No, it's okay. Yeah, you weren't. Yeah.
Yeah. I remember reading something about that all the energy that will ever be was all created at once, and it just changes or something like that. Is that semi-accurate?
Well, it depends, because I think if the universe is infinite, that makes no sense, because then you have an infinite amount of energy and matter. So that's why in astronomy we often talk about the energy density, how much mass, how much energy is there per unit volume in the universe. Because if the universe is truly infinite, with an infinite number of stars and galaxies, an infinite number of atoms, it makes no sense to say, well, that infinite amount of energy was born at once and changes form. But furthermore, there's another issue with saying that, which is energy is constantly lost. So what we learn as conservation of energy, like in 6th grade science class, is almost correct. It works on very small scales. But since the universe is expanding, it's actually constantly losing energy. So energy is still conserved, but not in the the simple way that we learned in the 19th, early 20th century. That's a good approximation for everyday lives, but energy is actually, as a whole, is constantly just disappearing, because as the universe expands and cools down, energy is being lost in the traditional sense. So in one way of looking at it is that actually we're constantly losing energy as the universe cools down.
I see. So if, as far as traveling from, I've heard it said by another astronomer that if the Earth was the size of the ball on a ballpoint pen, and it was in Washington, D.C., the nearest star would be San Francisco. And that's to give kind of, because we can't really fathom distance when it comes to all that. Do you think that at some point you think we'd ever actually be able to get a craft to another solar system?
Yes, I think it will be easier to do unmanned, which is unfortunate. I'm a lover of Star Trek, as you know. It'd be great to travel in ships, but I've resisted this for many years and thought, no, we got to have manned exploration. But unfortunately, those who say, that it would be easier to do it with small objects like little cameras, automated things. Here's the reason why. It's because of those distances you speak of are really not so bad if you can travel significantly close to the speed of light. But how do you do that? That's much easier if you have a smaller mass. It takes less force then to accelerate. So it's much easier to take a small object, and even then it's not easy. You still have to account for, if you're traveling at high speeds, a piece of dust is fatal, destroys even a tiny craft. So you have to, there's still extreme challenges. But I think the challenges of engineering, not challenges of physics, is what I always tell my students, is there's no law of physics that is stopping us from space exploration. In fact, physics works in our favor. I mentioned it so many times, always reminding people about time dilation. It's so often forgotten in fiction, in science fiction, is that the time dilation works in your favor, the slowing of time as you approach the speed of light. And so I think the problem of interstellar exploration is not one of physics, it's one of engineering. How do you get fuel? How do you get the shielding? But there's nothing in the laws of physics as we know them that would say interstellar exploration is impossible. It's difficult, but there's a big difference between difficult and impossible. Even extremely difficult is not the same thing as impossible.
Right. So let's touch a little bit on the UFO topic. You mentioned just a second ago that maybe unmanned would be the way to go if we are. Things are happening. People are seeing things. We don't know exactly what they are. Maybe there's explanations for some of them, but some there's absolutely no explanations for what people have seen that we know of. So I guess the question is, do you think that if we are being visited, it's most likely by some type of drone or something exploring? If you, again, I'm asking you to theorize. I don't know.
Yeah, yeah, absolutely. Yeah, no, I know, even though this isn't your great animation at the beginning of the podcast, I'm extremely skeptical of, like the gray skinned, humanoid. I think it's much more likely that there are drones with no beings would probably be a more likely first encounter, just given how much easier it would be to just take a small object that's, remote control is the wrong word. Can't have remote control for that distance because of the speed of light. But, you may be some sort of artificially intelligent robot, like a von Neumann probe or something like that from that von Neumann set. I think that is much more probable than craft with beings. I would be, though, thrilled to be wrong on that. I would be very thrilled to be wrong. I would love to have, a gray humanoid or some other, alien ships, see on TV say, hey, here we are, and we're aliens and we're real and we've traveled this, distance. I would be thrilled if that was the case. But I think that it's more probable and easier to imagine that, just like with the same problems we have, radiation, traveling through space, shielding, I mentioned, against, a speck of dust hits your ship and it's toast because you're traveling so fast.
Right.
So it's because of those things. I think that that probes with, unmanned is the wrong word, not just, men and women, but also, so it's also, we're not talking about humans, right? So I don't know, unpeopled, it's possible that I think that that's more probable of a scenario of first contact. Yeah.
And, the James Webb telescope is going to go up there, and, maybe it'll teach us a lot more. I think that's really fascinating. I ask this question of a lot of people that do come on the show with your type of background, and that is, why us? Why do you think, if we are in fact being visited, I'm not sure if we are or not, from another, say, intelligence of some kind, what would make us so special out there in let's just say our own galaxy?
Well, that's a great question. I think my best answer is that perhaps life is rare. So we're not alone, but what if there are only, I don't know, 10 civilizations in the entire galaxy? I'm not talking about the entire universe, I'm just saying into our galaxy. So it's potentially possible that if intelligent life exists in the galaxy other than Earth, it's still relatively rare. And also, we also have to realize that if there are other intelligent races, why would they not have the same spirit of curiosity and adventure and exploration as we do? Because let's turn the tables on your question. If we found some alien race, you bet your butt we would probably be spying on them before saying hello. We wouldn't say hello. We'd spy on them like they do on Star Trek, right? To not violate the prime directive, or whatever, right? We have our little station with the cloak so you can't see. So if the tables were turned, we would have some highly classified, listening post for the others. But I think a spirit of curiosity really cuts to the heart of that, as well as, like I said, the rareness. What if it is only 10 or 20 civilizations, which sounds like a lot since we have only evidence right now of just one, us, but that's a very small number given the huge distances you mentioned earlier. If it is only 10 or 20, which it could be, they're very, very enormously separated then on average if they're spread randomly throughout the galaxy.
Do you think that we will find intelligent life within a certain amount of time? Have you ever contemplated that?
I'm positive. I don't know I don't know how. I don't know if it will be SETI will be successful finding a signal, or is it that some portion of the UFO phenomenon is genuine? I think that's actually possible. That's why I'm here, right, on your podcast. And more full disclosure will come out. Speaking of which, you're going to get really excited when you mentioned the big thing coming.
Yeah.
If I'm not mistaken, I may be at least partially responsible for it if it's what I'm thinking.
Oh.
So we shall see. And if it is, I'll let you know after the podcast. Even I'll be like, oh yeah, this is because I've been pushing for very hard, not as hard as my colleague Kevin, Kevin Knuth, to let's get all the secrets out of what we know, because even if it's not, if some of these unknown craft were allegedly saying, let's say it's not aliens, but it's another country. What if it's Russian or Chinese technology? This is a threat to national security. We should stop laughing off all of this and take take it more seriously. Even if the percentage chance is small that something's real, it's worth the risk because the gain is enormous. I like to call this the 0 times infinity gamble, right?
Yeah.
The chances are close to 0, but not 0, but close, that, we're being visited by aliens in craft. But if we are, the gains in human knowledge are so vast that it should outweigh the risks of wasting time, quote unquote, as a scientist treating it seriously. I think that the gains are so massive that they outweigh the risk.
Wow. It's really, really difficult for me to not push you on what may be coming out that you may have something involved in. You probably
I could be wrong. I could be wrong, but I was pushing with Kevin for we're trying to get more stuff out because we're frustrated with how the immense all the secrecy. Because I think that in as a scientist, I'll tell you that so open science is a great thing. Secrecy is so incredibly detrimental to scientific progress. So let me speculate. This is speculation. Let's say, what if Roswell or something else? What if one of the claims of crashed craft is real, right? Let's say at least one claim is real. Where's all the great technology you reverse engineer from the alien craft? Why don't we have anti-gravity flying around? Do you know why? Because this is, again, I'm speculating. I'm saying for the sake of argument, let's assume some claim of a crashed craft kept by the U.S. government is true. Do you know why I imagine we would have made no progress then? Is because the way you make progress in science is you get thousands of scientists together. You don't have your 5 or your 10 who are, have the national security clearance. They will make no progress. Not because they're dumb or inexperienced. Absolutely not. I know many of the people who have come out and who have worked on the project, highly intelligent people who are laughed at for being crackpots, but many of them are not. However, the issue is that even 5 or 10 geniuses is not enough. Imagine Sherlock Holmes or a non-fictional character. Imagine a scientist in 1895. Imagine them trying to deconstruct my laptop. They wouldn't have the faintest idea where to begin. The only way we would make progress would be we would need like a Manhattan Project level thing. So Manhattan Project, I know, is classified, so that seems to defeat my argument. But I think that the more open that science is, the more progress we make. If we were in it all together. But right now, we don't know what's right and what's wrong, right? What's information, what's disinformation or misinformation, right? It's just such a mixed bag right now.
Yeah. And you're right. And there is a lot going around. There's a little bit of, I don't know if you pay attention at all. There's a little bit of friction in the UFO community, here and there. There's a lot of
a little bit. Yeah.
Oh, really? Yeah. There's some Facebook battles going on. I kind of pulled out of one yesterday, and kind of ended it with, okay, I'll keep an open mind just to stop the fighting. But anyway,
these Facebook battles are so pointless, though. If aliens are real, that is so much more important than our petty disagreements on social media, on Twitter, Facebook. This is so much bigger and more important that it makes all our squabbling look so petty by comparison. If even 0.1% of the claims made about UFOs and alleged aliens, even if 0.1% was true, that is so important that we should come together, not argue, and come together to research this.
Yeah. What do you think it would do? We have, we have about 6 minutes until the break. So what do you think all of a sudden we said, hey, there's intelligent life and we can interact with it out there? What do you think that would do to society and the world? Do you think it would pull us together possibly?
I used to think that. I used to think that a crisis would pull us together. And then came the COVID pandemic.
Yeah.
And then came George Floyd and then the riots and then the president tweeting and then we are so polarized that I'm actually starting to change my mind. I used to think that we would be pulled together immediately. There's aliens out there. No, I fear that what the pandemic has taught me is actually I used to think naively, I think that a crisis would pull humanity together. But unfortunately, what I'm seeing more and more is that there's more, that it fractures things even worse. I think that what would it be? It would still be, but here's the catch. I still think it would be the right thing to do. If the U.S. government or some other government knows the truth, is not telling us, I still think it would be for the best, for immediate full disclosure, even though there would be problems. There would be chaos and also disbelief. Oh, that's nonsense. What Kevin says is that there were my good friend Kevin Newth once said that there would be people where you could drag an alien out of a spaceship on live TV and do a vivisection, and they would still be like, "Oh, it's Photoshop." So like there's nothing you could do to convince some people. The president tomorrow could call a press conference and say, "Hey, everybody, aliens are real," and people would be like, "Whatever."
And even have one beside him. Yes.
And have one beside him. And people would be like, "Yeah, it's fake. That's Photoshopped. Oh, nice Hollywood special effects." So there is such a... So I think that I think it's for the best in the long run. But in the short run, if intelligent life is real out there, and we already know about it, I think that despite short-term negativity of chaos, first disbelief, then chaos, then you'd have religious fanaticism, there'd be all kinds of crazy stuff happening. But I think it would be best for the long run, so that humanity can finally put on some grow up and become an adult, right? I think it was Arthur C. Clarke, right? End of childhood, right? So I think that for the long run, it would be better. Just like the crises I mentioned, which are polarizing, I'm still hoping that they'll make change, that there'll still be long-term change, like police reform, healthcare. I'm still holding out hope that our recent problems with COVID and racism, that they still lead to a more positive outcome in the long run, but in the short term causes way more polarization. That's exactly what would happen if tomorrow government came out and said, "Hey, everybody, aliens are real." There would be first short term, very, very negative things, riots, etc. But in the long term, it's for the best of humanity, I think. I think it's worse the longer we keep it, because then it'll be like, "Oh yeah, we knew 75 years ago, we knew 105 years ago." I would be angry. I would be pissed, right, as a citizen and as a scientist. So I think that putting it off, if it's real, putting off disclosure, in the end is bad gamble. It's a bigger detriment in the long term to everyone.
Right. I've often said on the show that maybe the government knows something is going on, but doesn't know really much more than we do. But I do want to just say one thing also along the polarization of what you just said about what we're going through. There's also some really, mixed in with that, there's some wonderful acts of humanity out there as well.
Yeah.
You do see that in a lot. So it is mixed in, but unfortunately, I don't know if the media focuses more on, I don't really know, if that's why we see.
Right. Yeah. No, you're absolutely right. There are so many acts of kindness. There are people who, we've seen where the police, for example, joining with protesters and stuff, saying, "Look, we're not against you. We're on your side. We'll reform. It's good." There are those glimmers. You're right. But I think that the media focuses on the negative because it's a better story. Conflict sells. Yeah. You're not going to have a headline on the New York Times that says "kittens," puppies, or you don't write peace, exclamation point. You write war, exclamation point. And I've said this to my wife for years, right? I hate that. I hate that the news is always bad. I hate that because there's so much good in the world too. You're right. It's mixed in and it's hidden. But in the 21st century, we have YouTube. We have more independent media. When I was a child, you watched CBS, NBC, ABC, Fox, right? CNN. Those are your options.
Yeah.
But now we have more and more independent. And I think that a plurality of perspectives is good. It keeps us honest with ourselves.
Yeah. Yeah. We're going into a break in just about 1 minute. So I just want to, I don't know if you can make this just quickly. I heard you mention earlier something along the lines where maybe in my lifetime not knowing about dark matter. Do you think you will know? Again, we only have a minute here. Do you think in your lifetime you will know what dark matter is?
In my opinion, yes. Yes.
Really? But
it's going to take longer than we think. Everyone's always quoting 5 or 10 years. I think those are way too optimistic. So I think we're still decades away. But I feel this is an opinion. It's not a scientific statement. In my opinion, we're going to get there within my lifetime.
Wow. Excellent. Well, all right. So we are going to head right into the break right now. So everyone hang in there. And for those of you in YouTube, you're going to have to put up with my commercial. And thank you. And we'll be right back. Hello, everyone. Well, this is another podcast commercial. I hope it's better than just dead silence. This is for, of course, the people over at YouTube and now over at Facebook as well. So I'm painting away, as I've mentioned many other times since I'm not working. And I'm going to show you a couple things here. First of all, I have to say that I was pretty happy because I did this this artwork, and in just one single day, I sold it. So that was pretty exciting. And last week, I had shown an image of what I had painted, and that was the winter triangle. And guess what? That sold too. So I am selling some pieces now. I will tell you that I worked out a really good deal, and I'm actually very willing to work out really good deals. So if there's something over there that you like, and that's over at martinwillisart.com, go check that out. If there's something over there that you want and you are looking for even more than 50% off, because that's what happens if you actually enter the code UFO. So if you enter that code UFO on checkout, you will get 50% off. I'm showing you a couple things that I'm doing now. The pictures aren't exactly straight here, but whoop, they just went by. So I started doing a little bit what's called trompe l'oeil, which means it kind of fools the eye. That's French for fooling the eye. I'll get back to that. This is a landscape I did last week. And here are some of the UFO paintings that I have left. I'll work a great deal with you. I have a couple more in the works. Probably not going to do any more after that, unless someone wants something in particular. And if you do want something in particular, it's very easy. All you have to do is just tell me what it is, and I will try to work that out. I also did this this lighthouse piece next week. Well, here are the trompe l'oeils that I did. A crystal ball, a larger crystal ball, and anyway, yeah, and then there are two. This one is already gone. It's already sold. And anyway, I just want to thank everyone for paying attention. And remember to go to martinwillisart.com. And one other thing, besides the UFO code for 50% off, I have a kind of a hidden link. It's not on my website. It's only in the show notes and also in the notes below on YouTube. And that is a link directly to just UFO paintings. And so if there's something there you want, please do contact me at martin@podcastufo.com, and we will work out a deal, because that's what I am looking to do. Is I need to paint. I love painting. It really relaxes me, and but I can't paint unless I get rid of some of the paintings, sell them. So anyway, I hope you enjoyed this little infomercial, and we'll be back in a few minutes.
In 3, 2, 1, go.
All right, welcome back. My name is Martin Willis, and my guest this evening is Matthew Szydagis, and I hope I'm saying that right. Matthew, is that close?
You're doing extraordinarily well, actually. I mean that sincerely. Yeah, you got it. Yeah.
Awesome. Well, that's great. How long did it take you to learn that?
Me.
Yeah. Anyway, so I've been really enjoying this conversation immensely, and there's just so many questions. Now we're basically talking about intelligent life, so we'll get back to that. And so the James Webb, I actually got to see the James Webb. I was at the NASA down in Baltimore Goddard Space Center, and saw people working on it. It was great. They were in these, it was in a sterile room, and they were in, white suits and working on this thing. so many years go by that they're working on this thing to make something really special. Now, I remember when the Hubble went up, they had to replace the lens or something, or a mirror, or I can't remember what it was. But this should be good to go when it actually goes. And what do we expect that we're going to learn from this?
Oh, it's going to be a vast amount. It's going to, because better, it's, a successor to the Hubble Space Telescope, but so much more. If I'm not mistaken, I think it'll also be able to look for exoplanets, continue the search for exoplanets. So the amount of astronomy, the amount of science you'll be able to do will be immense. It spreads, the amount of science you'll be able to will be across many different parts of astronomy and cosmology. So, going back to my reference, the Hubble Space Telescope, right, that we think about the pretty pictures, right? But it's way more than just about pretty pictures. It's about doing really good science, seeing into the depths of the furthest reaches of the visible universe.
Yeah, I just want to address this quick question here. Martin's trying to get out of the podcast UFO. I know he's probably just joking, but I am painting because, first of all, I'm not working, and I used to paint. It used to be my job to paint, and that's how I survived for at least 3 years of my life. And that's all I'm doing. It's a passion of mine, and there's in no way that I'm looking to get out of podcast UFO. I've been doing this show. It's coming up in 9 years in just a couple of months. I love the topic, and I love speaking to people like I am tonight. So I'm not going anywhere. I'm just painting. That's all there is to it. Seems like everything turns into a conspiracy.
Yeah.
Yeah. So is there any type of information that we could get from the James Webb Space Telescope that's going to tell us that there's in life of some type on by seeing a planet, not a planet directly, but the gases from a planet or something like that?
So yeah, atmospheric studies of exoplanets is a really exciting future direction. But we have to be, so one thing you have to be careful of is that even if we detect the, so-called right molecules or gases for life, that everything always has multiple explanations. So for example, a planet could be habitable, but empty, or it could be inhabited and we have evidence from the atmosphere that there are life forms, carbon-based life forms like us, but they're not necessarily intelligent, right? Could be plants and animals. And so we will know a lot and it'll be exciting, but we also have to be careful that we're still not going to know as much as we might like. That we still don't have, the Star Trek level of, sensors to remotely detect things well. So it will be nevertheless extremely exciting if we are able to detect and study not just the sizes and orbits of extrasolar planets, but also their atmospheres. So, but it'll still be a tough sell, a tough leap to go from, look, we detected all of these organic molecules are clearly in the atmosphere of this planet. There's still another conceptual leap to connect the dot from that to saying there are life forms there, and then another leap to say they're intelligent life forms. I'm still very excited, of course, and very optimistic about the future of astronomy, especially in extrasolar planetary research, which, as you know, my friend Kevin Knuth is a leading expert in.
Yeah. I think it's an exciting future. And then, like, to say, if we did detect something, what would be our next step? Like if we found something that's it's possible that it's intelligent life, say they have pollutants or whatever.
Yeah, well, that's a great question. The next step is very challenging because it depends on distances, right? Going back to your ballpoint pen from earlier. In DC, the problem is the speed of light. The problem is if we detected, let's say, fairly strong evidence of intelligent life 20 light years away. If we said hello, it would take 20 years to get there. and 20 years for a response. That's 40 years. I like how in the movie Passengers, they got this right. Rare science fiction.
Oh yeah, that's a great movie.
Right. Remember, they're like, tech support will be back. Will answer you in 17 years, right? So, and that's a very fundamental. It's a very fundamental limitation. You know, it's all fun to speculate about faster than light, but every exception to the speed of light we know about. The big catch is no information can be transferred faster than speed of light. So it's very, very unlikely we will ever have faster than light communication. That would be wonderful, but it's very unlikely. So the next step would be very tricky. Depending on the distance, maybe what we would want to do, I think I've heard NASA's kicking around plans to maybe send a very small spacecraft to Alpha Centauri in 50 years or something. So if something is close enough to where we could send some very tiny craft to check it out, I think that a logical next step might be go take a picture rather than try to send a signal. You know, send a very tiny probe that, you know, again, we don't have the technology to do this yet, but we're getting there, and I'm confident we will, that we have some sort of tiny little robot probe that goes and snaps a picture with enough resolution, obviously, to see there's cities on the surface. I think that, especially also given how cautious, you know, humanity would be, that's way more likely. So if you were looking for me to say, oh, we turn on the radio and try to say hello, that's unlikely for so many reasons, speed of light, and also we'd also be very cautious.
Well, what about, you know, this is probably totally unrelated, but possibly, I think it's called quantum entanglement.
Oh, I knew you were going to bring that up. Yeah.
You did. How'd you know?
Because that's everyone always says whenever I say no information travels faster than the speed of light, before 10 seconds go by, someone goes, what about quantum entanglement? So, but no, I'm glad you brought that up.
I was a little bit late.
Because no, I want to put that to bed once and for all. Okay? Quantum entanglement is really awesome, really creepy, and really weird, really cool. However, it's still not going to help you with communication. The way quantum entanglement works, and so in this case, Einstein gets the last laugh again. Because yes, it looks like information is being conveyed faster than the speed of light, instantaneously, in fact. However, big catch. So the way quantum entanglement works is, let's say I have two particles and they are they're entangled where if one is spin up, the other spin down. That means that even if they're separated by, you know, kilometers, if I measure one is spin up and this one's kilometers, light years away, it's spin down. Right away, it's got to be. If that one's spin up, that one's spin down. Unfortunately, you don't know which. So basically, quantum entanglement is useless for communication. Imagine a communication system where you didn't know the difference between 0 and 1, right? If it was binary or yes and no. It's completely useless for communication. You can transfer garbage information, random information. You cannot use quantum entanglement to convey useful information faster than the speed of light, not with our current understanding of physics. And as I said earlier, even though we still have a lot to learn, our current understanding on the little bit we do know is pretty solid. So I hate to dash those hopes because, trust me, I would love to have, you know, what's called in science fiction, from Ursula Le Guin, an Ansible, right? A radio that's just instantaneous, faster than light. That would be great. It's extremely unlikely. And even if it is workable, it's probably something else that we haven't imagined yet. It has nothing to do with quantum entanglement. Is not going to help you. So like I said, Einstein gets the last laugh because, yeah, it looks like information is transferred faster than light. It's garbage because it's random. It's spin up or spin down, but you don't know beforehand which one's up and which one's down. So in the end, it's useless information. It's like, imagine a Morse code where all the letters were the same. Or random, right? It's useless. Yeah.
What about, you hear every now and then, and science, or it comes out somewhere that they think there can be speeds faster than the speed of light. Do you ever look into any of that? I mean, is that a possibility?
Yeah, it always gets shot down. Either one, it's a mistake. Like when we thought we discovered faster than light neutrinos, it was a loose cable. So either it's a mistake, or if it's correct and true and good science, And then when you read the paper, the scientific paper, not the popular press article, but you go dig in the scientific paper, you'll find that the catch I just told you is right there. Like, oh, but you can't convey information faster than the speed of light. So what the heck? So those are the two options for everything I've seen in this category. Option one is always, it's just bad. It's wrong. It's bad science. It's incorrect. Or the other option is it's correct, but it's hyped up in the media. And if you look at the truth is far less exciting. Now, that being said, I should emphasize that you don't need faster than light to explore the universe. Remember the time dilation that I mentioned earlier. I mentioned this in my SCU talk. I always give my students this problem for homework is, you can reach the Andromeda galaxy, which is 2 million light. Do it in 50 years if you traveled 0.1 meters per second slower than the speed of light. You don't need faster than light. If you can go arbitrarily close to the speed of light, 99.9999999%, you can go as far as you want in the universe in as short a time period as you want. So there's no limit to exploring anywhere just because you can't go faster than light. It's a huge mistake in science fiction to be like, oh, you need faster than light to go anywhere, because the distances are so big. But the distances contract. So just like how time dilates, so another relativistic effect is that the distance appears to contract to the traveler. So those distances contract as space-time warps as you go near the speed of light. So going near the speed of light is all you need to explore the universe. You don't need any exotic, faster than light, this and that. It would be more fun. Don't get me wrong, because if with faster than light, you could be back home for dinner. If you're traveling just below the speed of light and you do what I just did, you go to Andromeda in 50 years, everyone on Earth is dead because it's been 2 million years that passed by on Earth. So there is a downside, definitely, to not having faster than light. But faster than light, so think of faster than light as the cherry on top, but it is absolutely not a requirement for interstellar travel being a reality.
Yeah. I had someone on with a science, very good science background, real nice guy, and I can't remember exactly what his theory of travel had something to do with space-time folding, or like coming together and folding and going through it that way. I really, I'm kind of butchering what he said, but it was really fascinating. Are there other theories? I know there's the wormhole theory and things like that. What do you think about all those different types of theories?
So a lot of them fall into the same category, which is they have the same difficulty that faster than light does, which is they would require negative energy. We don't know how to make that. So you would need some sort of substance that would have an anti-gravitational like effect that could hold open like the throat of the wormhole, for example. So all these space folding and wormhole ideas, they all require something that, and a lot of it, a lot of energy, of a form of energy that we not only have no evidence of, we don't even have a theory that says it should exist, and not in large quantities that are practically usable. So that's the catch, is you need some sort of anti-gravity, negative energy type thing. I mean, in fact, I have a YouTube video on this, so hopefully people, here's a shameless plug. Well, you had a commercial, so I get to. So I have a YouTube video about time travel where I talk about time travel. One of my favorite topics.
My next question.
Yeah.
That was actually my next question, but anyway, go ahead.
Please. Yeah.
Yeah.
No, go ahead.
I just wanted to ask you, and I do want to get into, the possibility of propulsion that you were going to bring up in the 0 point energy and all that stuff.
Yeah.
But I was going to ask you, and I was unfamiliar with this, if you ever looked into time travel and what the possibility of that is.
Yeah, I got a TEDx talk on it. I got this 20-minute video that I hope, since my last name is so unique, if all your viewers, if you just stuck my name in, they don't need the link because my name is so unique. Just put in Szydagis time travel and there's my YouTube video. I'm really proud of it. I have currently more views than Neil deGrasse Tyson's video on the same topic, PBS Space Time. I have more views than Kip Thorne, who's got the Nobel Prize with his time. However, I have not caught up yet with still some scientists have not caught up yet. I think Brian Cox, but I've got like 500,000 views, but I hope to get it even higher.
Well, I will tell you what I will do is
yeah. So Brian Cox, yeah.
No, I'm just going to say I'll link that in the show notes.
Yep.
Okay.
Okay. Cool. Yeah. Brian Cox has 1 million. I still got to catch up to him.
Wow. Yeah. And so your thoughts in general on that topic, is it a one, is it omnidirection or one single direction?
So yeah, I'll try to, in order to not stray too far into this very different topic, I'll try to give you my most concise answer, which is, yeah, if you look at my video, basically my conclusion is that it's extremely unlikely that people or large-scale objects will ever be able to time travel to the past, like in science fiction. But maybe one day, communication will be possible to the past, like a tiny fraction of a second or something, which would be revolutionary in itself. My colleagues think I'm too optimistic when I said that, which is really ironic because most people say I wasn't optimistic enough, right? What, just information, a tiny fraction of a second, not people in a machine? But it all boils down to the ability to harness negative energy, which we don't know how to do. And that's what you need for time travel to the past. That's what you need for FTL. That's what you need for wormholes. So all those awesome things, all those really fun things, all require this secret sauce of it goes by many names. It's also called exotic matter. It has nothing to do with dark matter or dark energy. It's yet another crazy term. There's exotic material is another term for it.
Yeah. FTL is faster than light, right?
Yes. Yep.
Yeah.
Sorry, I slip into acronyms all the time because so my research for dark matter is funded by the Department of Energy, the DOE. They love their TLAs at the DOE. There's the T20 and the this and the CD4 and the like. Oh yeah, they love their acronyms.
That's pretty funny. So I want to go into the 0 point energy, and in about 15 minutes or so, we're going to take calls. I know there's a lot of questions been popping in. 0 point energy. A lot of people get that wrong, and it's been used in the UFO community. Can you explain what the scientific explanation of that is, please?
Yeah, I will do my very best because it is very complicated. So I want to try to explain it in reasonable terms because I do want everyone in the audience and viewers to be able to understand. So I'll do my very best. So the dark energy we mentioned earlier is probably the same thing. I can't say it with certainty because 0 point energy has to do with particle physics. Dark energy is astronomy, but it's our best guess that they're the same thing. And so what is 0 point energy? So like you said, this is extremely poorly understood and misunderstood and misused. So the way it works, and I should be very clear that this isn't some wild-eyed hypothesis. This is scientific fact because we can measure the effects of what I'm about to describe to you. There are many experimental verifications of this. So what 0 point energy is you have, so imagine you have vacuum, but vacuum is not perfectly empty. Even if you have a vacuum with no atoms, no loose protons, even electrons, you have particle-antiparticle pairs zipping in and out of existence. So like an electron, anti-electron, proton, antiproton, balanced.
Mm-hmm.
So yeah,
I was just saying, wow, I didn't know that.
Pairs. Yeah. So now it's a matter of debate though, whether the virtual particles I just said are they real in the sense, do they have an ontological, existence, or are they just a handy mathematical tool for calculation? They do have experimentally verifiable results though. So what 0 point energy refers to is that even the vacuum of space itself is not completely empty. It has energy. You can borrow energy from the vacuum. You can produce particle-antiparticle pairs. Now, the thing is, we don't know with our current level of understanding of science and technology, we don't have the faintest idea how to turn that into something practical, right? How do we tap into the 0 point energy? Oh, it's free energy. It's everywhere. And I mentioned that it might be the same thing as dark energy. That's 70% of the universe. So isn't this everywhere? Can't we use this to power everything? And the key is we don't know because it's such a small effect. It's a very large amount of hidden energy in the universe on large scales. But on small scales, it's a very, very tiny effect. So something that always comes up, especially in the UFO community, is the Casimir Effect. This is one of the ways we prove zero-point energy is not just some crazy idea, but actually has experimental implications. So in the Casimir Effect, you have two metal plates, which in a vacuum, a force may develop between them, even if they have zero electric charge. And, nowadays we can zero out the charge of something so well, we can count individual electrons. That's the level of technology we have. In my own dark matter experiment, we count electrons. So there's 1, that's 3 electrons, that's 2. That's the level of precision we have in the year 2020, and have for a while. So we can do this experiment with completely neutral plates, not a single extra electron, which would mess up the result. And what happens is that an electric charge and a force develops between the plates because of these virtual particles. You have virtual electrons, anti-electrons. But as I cautioned earlier, there are multiple ways to interpret that. You can say, well, virtual particles are virtual, right? They're not real and they're just a mathematical tool. But the consequences, the experimental consequences of zero-point energy are quite undisputably real. The Casimir Effect experiment I mentioned, this has been done. It was in the 90s. It's been done multiple times. We're talking really, really tiny amounts of energy. Right. So if your free battery on the zero-point energy would really, really suck, right? It would power, your laptop for, a tiny fraction of a second, if at all. And so we don't know how to take that, blow it up, big scale. Let's make it practical, right? Wormholes and all these other things that require, we don't know how to take this teeny tiny Casimir Effect with zero-point energy. How do we make it, grand scale and capitalize on it for something, propulsion, power, etc. But it's real. Zero-point energy is not a crackpot term. It is real science. It's just that people will sometimes jump to conclusions on how easy it is to extract it and make it practical.
Do you think that CERN will do some work that'll point more into this direction? Or, yeah, go ahead. I'm sorry.
No, so I think, that's a really good question. I not necessarily CERN, the Large Hadron Collider, but there are the ways we're exploring zero-point energy are very different. So we don't use giant colliders. There's 2 main ways of exploring this, and they're very different. One is astronomy with telescopes, which sounds weird, right? I'm talking about, particles here. And the reason why is because, remember, we think dark energy is the same thing. And so the way we study dark energy is using telescopes and looking at the expanding universe. On the opposite end of that, the way we look at dark energy or try to study it is there are some theories that dark energy is a particle, just like dark matter, and maybe we could measure it on the tabletop. So a collider like at CERN is not the right tool for the job, as far as we know. So our tools are telescopes studying dark energy, and then we have tabletop experiments where we are trying to look for new forces by levitating like micro spheres of glass, of quartz, and then and making sure we account for gravity, and there's no electric force because there's no magnetic field, and look for evidence of additional hidden forces. And so that's one way that this problem is being tackled.
And what is how has gravitational waves played into what you study?
Great question. So it has played a part, but only indirectly. So I want to connect the intellectual dots because it's not a direct connection. So what gravitational waves have done is they've provided further confirmation of Einstein's theory of general relativity, therefore killing off many competing ideas against dark matter, saying, we just don't understand gravity. If you look, not all, but if you look at some of the modified gravity ideas, they would predict either no gravitational waves or a different form. But gravitational waves matched the relativistic prediction and still do, right? It was multiple detections, LIGO still detecting today, Virgo, all these new experiments. So indirectly, what the gravitational wave discovery has done is said, that relativity is again very, very solid, making it a very, very clear that it's very unlikely that dark matter is that dark matter is wrong, and that we just have to modify gravity. So does that make sense? So there's kind of the indirect connection.
Yeah, I'm sorry. I posted that question up on the chat. It kind of threw you off a little bit. I saw you read it and lose your concentration.
Yeah.
Yes, thank you for that. So have you ever heard of what he's talking about, the Electric Universe Thunderbolts project?
Yes, I actually have. So the asker of the question is going to be really angry. It's it's complete garbage. It's nonsense, because a theory is only as good as it explains experimental data, and all these theories by non-physicists or people who say that physicists are just complete garbage, just nonsense. It can't explain gravitational waves. It can't explain cosmic microwave background. I could go on and on. I could probably list 200 or 300 phenomena that the electric universe thinks it explains. I once asked someone about electric universe. I said, but what about the bullet cluster and gravitational lensing? And they hemmed and hawed and had some pseudoscientific explanation. It's complete garbage. It's because you have to remember that theories are only as good as you need they need to be confronted by experimental data and observation. And the electric universe fails completely miserably. It's not science. It's just a pretty fun idea, but it's not science.
I've heard the term you just mentioned there before, gravitational lens. What is that?
Mm-hmm. So that's where gravity can bend light. So gravity can, and we first observed this in 1919. Sir Arthur Eddington went out and found the first evidence of Einstein's theory of relativity by looking at the bending of light from our own sun. And nowadays we use gravitational lensing on astronomical scales as a tool for studying how much matter there is out there. So gravitational lensing, it tells us how much it is basically gravity on large scales acts like a giant, eyeglass or contact lens, right? Gravity can bend, a strong gravitational field bends light rays.
Wow. And is that what black holes do?
Black holes? Absolutely. Yeah. Black holes have very strong, very aggressive lensing effect, especially, near the event horizon, extreme distortion of light.
Yeah. What does that mean? I know recently they said that, while I read somewhere that they've discovered a black hole, not nearest, but nearer than, near us, that they were unaware of. Do you think there's black holes out there that a lot of them that we just don't know that are actually around a lot? We have a call coming in, but
no, because we have lensing studies we could do, so we look for them. Yeah,
I see. Yeah.
Yeah.
Oh, okay, so that's how that works. Yeah, he's screening the call right now.
Okay.
But anyway, it's all fascinating to me, and just the fact that that black holes, what happens to them, and once they happen, they're basically forever. As far as we know?
No, not at all. They evaporate over time. They disappear. That's called Hawking radiation. Now, to be clear, though, to be fair, especially since I dissed the electric universe earlier, to be fair, we've never observed Hawking radiation. But our best theories and models say that black holes would evaporate over time, but it takes, I can't even use the word billion. The word billion is too small, way too small. It would take so many years it would take 10 to the very large power number of years for us to ever observe a black hole evaporating. But yeah, no, they're not necessarily eternal.
Yeah. I forget what the saying is in physics, but it's like order to disorder. Everything, goes to disorder.
Entropy.
That's right.
Is that what you're thinking? Yeah.
Yeah, that's what I was thinking of. We have a caller now, Dave, calling from LA County. Dave, welcome to the show. Oh, it's my fault.
Can't hear.
That's okay. Now we get you. Now we got you, Dave. Welcome to the show.
Great, thanks. I was wondering if Matthew had ever considered. I mean, I'm sure he has. But he's an incredibly intelligent man. The gravity, such as at a black hole, the event horizon, the speed of gravity can be faster than light, which is why it doesn't allow light to escape. So, wouldn't it be possible if you could, with some exotic technology in the future, if you could create a divot in ahead of your ship that you could fall into and make the divot deep enough that you could fall faster than light forward, maybe make one behind you of negative gravity that could push you faster than light, like in concert. That might be a good way to travel faster than light, or am I completely delusional here, or what?
So no, there are ideas similar to what you say. I hadn't mentioned, there's the Alcubierre warp drive, which is good physics, good science. It's a good idea, but it would again require negative energy. With the idea you suggest with a black hole, I don't see how one would do that without getting crushed would be the problem. Your point about the speed of gravity and light. So the speed of so it's again the catch is the information, right? Is information transfer. So in your example with the black hole, so the information is lost, then you fall through when you fall through the event horizon, you can't get back out. So no, you have some interesting ideas there. I don't see how the two big things I see are, as I said, first is how to do that without some sort of negative energy, like you said, in the back of the ship. That's always the catch for faster than light. And the other thing was, how do you avoid getting crushed?
I'm picturing it like a carrot on a stick. If it was projected out in front of the ship, and there was a big divot, and the ship was falling into the divot continually, but it was only, it was just held out there so far away that you simply fell forever until you turn it off. You turn it off, you stop falling. It'd be like a carrot on a stick, and kind of a projection.
Kind of like an artificial black hole.
Yeah, it's like you project a deep hole that you could slide into, but it always stays out there in front of you.
It's probably thousands of years beyond what we could even start to try to think of.
Yeah.
Doing
I'm thinking that's probably a good way to slide forward through space at really, really fast speeds.
Yeah, I'd have to think more about it. So you're basically what you're talking about is like a gravitational assist, but taking it on steroids. Yeah. One downside to it's not necessarily a downside, but one downside to it would be you would unintentionally always be time traveling to the future one way. So if you're that close to a black hole all the time, what happens is that a few hours passes for you, but thousands of years back home, because remember that what you just described, warping of space and time are two sides of the same coin. So if you're warping space, you're also warping time.
Acceleration, it doesn't matter, right?
Well, no, acceleration makes it even worse. So yeah, no, you'd have pretty severe warping of not just space but time, because whenever you have warping of space, you also have warping of time. That's not necessarily a bad thing. I wouldn't mind a one-way ticket to the future, out of COVID and out of today's era. So that's not necessarily a bad thing. Yeah.
Great. Well, thank you so much.
Thank you for your call. Thank you.
Yeah, thanks for the call. The line is open, and that number is 855-472-5483. We are taking calls, and you are welcome to call and ask a question. That was actually a really good question. Another call is in, just waiting for it to get screened. So, yeah, this is all very fascinating. I heard of, there was this other guy that was talking about gravity, like that's why there's no G-force that are destructing, the crafts or the people, is because they're actually in a constant fall, which is quite a very interesting theory. Not sure if it had any really meat to it, but here we have Andy calling from Connecticut. Andy calls in quite often. Andy, welcome to the show.
Hi, Andy.
Hi guys, good show. So my question is, and I'm sure this is a little bit off subject, but what does Professor Matt think of the idea of all points in space and time being connected, and what that might mean about consciousness and astral projection, out of body experiences? It connects to spirituality. I know this is a little bit weird, but there was that famous comment made by the Skunk Works director during a breakfast where Jan Harzan was present, and that was the comment made that we've got technology that would knock your socks off, and it he referred to all points in space and time being connected. And then I'll take your answer off the air.
All right. Thank you, Andy.
Okay, thank you. I think that's a great question that requires me some deep thought. So I have absolutely heard of this, and I have issues with it. That doesn't mean it isn't right. It would just mean that I would have it's very difficult for me to understand these phenomena in the context of our current understanding of science, because I mentioned the quantum entanglement earlier, where you can have in quantum mechanics non-local effects that do seem to imply that there is some sort of ability with a faster than light communication, a connectedness in distant points in space. But as I said, the catch is the lack of information transfer in that. So in my opinion, I do always this. I say the same thing as I do with UFOs. So I think hopefully, so the most honest answer I can give is that I think we have in some of the phenomena you mentioned, like astral projection, that it's similar to issues with UFOs, where it's not considered scientific because we didn't fully try it. So it's kind of a tautology, and so we didn't fully study it, and therefore it's nonsense. But why can't I go study it? Oh, because it's nonsense. But shouldn't I check? No, why waste your time? So because it's a tautology. And so I do think that even though it's extremely unlikely to be right or correct, it is worth sometimes exploring those off-the-wall ideas. On the off chance, I mentioned earlier the 0 times infinity gamble, as I like to call it. On the off chance one of the crazy ideas is right, because we have to realize that at one point Einstein's idea is that the speed of light was the maximum speed. That was considered dumb and crazy.
Wow.
And so today's nonsense does sometimes become scientific fact, but as I said earlier, it has to be confronted with experimental data. And I do know there's some very interesting things, going back to quantum entanglement, that's been happening in quantum mechanics and quantum physics. So I don't want to just be completely dismissive of the idea, but I am skeptical. And if there was actually hidden, government technology knowledge, and like I said earlier, as a scientist, not just a citizen, I would be extremely angry and deeply offended, because if these things that you mentioned are real, scientists should be studying them and trying to understand how they work and what causes them. They should not be kept secret, but and then laughed at as like, oh, we already know that doesn't work. We should crack that open and then study that. So if the caller's right, that that there is, and I have heard this, obviously I've heard this myself and from Kevin, that these are real technologies. There's the CIA program for psychic spies and stuff like that. Not necessarily technology. I use that word wrong. Could just be natural, something of the human mind on its own. I would be furious to learn that it was real, and the scientific community's been laughing at it for years, and the U.S. government's had this the whole time, because we should be studying. We should be trying to understand what the cause is. Is it what type of wave is being communicated? What force? If these are real phenomena, we should apply the scientific method and determine what the causes are, and not just laugh it off. So that was a long-winded answer. Sorry.
No, I love that.
Yeah.
We now have Greg in Samaria. I think that's my first Sumerian call. Greg, welcome to the show.
Hi, thank you. All right, you have to promise not to hit me before I ask this. It's
Wait a minute. First of all, this may be an excuse. What time is it there right now?
Well, it's several years. It's like 1000 BC, actually. Samaria.
Are you the good Samaritan or the bad Samaritan?
Anyway, yeah, go ahead. Go ahead. Ask the question.
All right. Some great minds like Steve Hudgens from MUFON and all that believe in this guy. Could you, in 1 millisecond, tell me everything he got right? With the Worlds of Collision, Velikovsky.
Do you know the name?
Anything at all?
Worlds of sorry, the internet broke up and I couldn't hear. My connection broke up. Worlds in collision, and what was the other thing?
Milaskovsky. He's the one who has the ping-ponging, I think it's Venus, was ping-ponging around the solar system. And I think it called Noah's Flood. I can't remember for sure. There was a lot of ping-ponging and really strange physics.
Well, we actually, we know the history of the solar system incredibly well. So the planets were in different positions over time. And we have solid, we actually have pretty good models for how the planets moved over time and what their climates were. They're not perfect, but what their climates were billions of years ago. And I don't think there's any good scientific evidence for any of those ideas.
So there's like no chance at all that Venus could be ping-ponging around, or that Planet X could be looming right over the horizon, ready to kill us. In your opinion, right?
Well, no, there could be in the Kuiper Belt. There could be a very large additional planet. There is actually some evidence of
way
that.
Out there, way out there.
Yeah, no, and yeah, there is evidence
every few yeyears.
Are you referring to the Nemesis, the Nemesis hypothesis?
So. Yeah, it's not one of my favorite theories. I'm a little fuzzy on it because I kind of like started throwing things when I was reading it. But yeah, it's supposed to come around every few thousand years, I think, which I don't see how that would be remotely possible.
Well, we do have meteors and comets that do come around, and in some cases in what seems to be on regular cycles, like if you look at the extinction history of Earth. So space is dynamic. So one thing that is correct, space is dynamic. So this cartoon that we have, picture of the solar system from childhood, is not fully correct because the solar system has shifted over billions of years. So you don't just have, there's the sun and Mercury, Venus. That's how it is now. But over billions of years, things can switch up. I know I've seen one astronomical model where Jupiter was once much closer to the sun billions of years ago, and then it shifted and kicked things around. So there is, but a ping-ponging effect would be very difficult to explain gravitationally, because why would it go and come back? Because remember that gravity is only attractive and it can't be repulsive.
Anybody else's orbit, which is kind of crazy.
Yeah, no. Everything is interconnected, because even though the planets are very far apart, gravity does have an infinite range, has an infinite extent. So, like Jupiter's gravity is a non-negligible quantity in our solar system, right? It's not just that the sun's gravity is the most important, but Jupiter's gravity is very non-negligible. Yeah.
For its size. Thank you, Greg. So yeah, I mean, there's been talk about, an elliptical orbit that we don't know about, that something that may come around every 800 years or something like that we have absolutely no idea until it shows up. How do you think we are set as far as, one of the things, of course, that always makes me a little nervous is asteroids, getting hit by an asteroid or something like that. Do you think we have a long way to go on that, or do you think we're fairly safe as far as detection? And what do we do if we see one coming right at us? I mean,
we're screwed.
We're screwed. I listened to Astronomy Cast. I don't know if you've ever listened to that. Yeah. With Fraser Kane. One of his sayings is, the universe is out to kill us.
Thank you for that question. Yeah, it just ties in nicely with our last caller. No, it's not a question of if; it's a question of when. And what you're saying, is it likely? Unfortunately, statistics doesn't work that way. But I'm really glad you asked that. That would be like asking the following question: I'm playing cards, right? Blackjack, poker, whatever. I'm losing. Oh, you know what? I'm due for a win. The law of averages. That's not how it works. An asteroid could come tomorrow, or not for another 10 million years. And I can't say one or the other is quote unquote more likely. That's not how statistics works. Statistics is better applied when you average over time. So but also, there's different schools of thought on it. There's Bayesian and frequentist statistics, stuff like that. But basically, yeah, it could be tomorrow, right? As far as detection, people work hard on it, both astronomers and amateur astronomers detecting near Earth objects. That's what they're called, NEOs. No, but you're absolutely 100% right that we could just get completely unlucky. And I worry about it too, because we don't have our SHIT together as humanity, basically, and we would have to stop treating science and technology as a joke, funding it more, not just in the US, but around the world, treat science seriously, because we're not ready. We're not a science or technology. It's not like the movie Armageddon or Deep Impact. There's nothing we could do. Nuclear weapons, nothing. So I used to think, oh, we're fine. We'll launch some nukes at it. And then I sat down and I realized, it's not going to do anything. A big enough rock, it would just make a dent. The entire world nuclear arsenal would be like, dink, because these are, these potentially big rocks we're talking about. And so I completely agree with you. And I think that this is one of the reasons why my colleagues think I'm crazy when I say this. We need to become an interplanetary society. Yeah. I'm disappointed. When I was a kid, where's the moon base? Where's the Mars colony? It's 2020. We still don't have a moon base. We're pathetic. We have all our eggs in one basket. Yeah. One bullet takes us out. COVID-19. Imagine if COVID-19, instead of 3 or 4% fatal, was 30% fatal, like MERS. Yeah. Or SARS, but it was more contagious. We'd be all dead right now, right? Yeah. And that's why I think it's so important we become interplanetary, because if it's not a virus, then it's a comet or asteroid. Something's going to get us.
Or volcano.
So we need to spread out. Volcano, Yellowstone, right? Super volcano. We need to spread out. And unfortunately, that's going to take billions and trillions of dollars and euros and yen and all that. I don't think we have the willpower for it. I wish we did.
Did you follow, I don't know, was it maybe 4 years ago, people were signing up to go to Mars? Do you remember that?
Yeah.
I forget what it was called.
Yeah, I know
a lot of people.
Yeah. No, but I think it was premature. Even though I just said we have to become interplanetary, we have not solved all the problems.
Yes. Right.
What if there's cosmic rays, gamma rays, radiation? What if there's a solar flare? Boom. So we have not solved all the problems. I want to, but we shouldn't rush and just kill everybody doing interstellar travel. So we have to be cautious. But I worry that we're being too cautious and we're not trying hard enough. All these problems like radiation, there's no law of physics stopping us. This is an engineering problem. We're smart. We have engineers. This is an engineering problem. There's nothing in the laws of physics that's stopping us from first becoming interplanetary and then eventually interstellar.
Yeah. This question up here, if we knew of another planet beyond Pluto, we would have known it by now, from an astronomer. But they actually do know of bodies that can be fairly large and almost considered a planet, don't they? Or similar size to Pluto, maybe even bigger?
Yeah, there's plenty beyond Pluto. There's the Kuiper Belt and the Oort cloud. And actually, it's not true that we would have known about it. And here's the reason why. So it's a very strange kind of counterintuitive effect, but sometimes in astronomy, it's easier to see far away than close by. So for example, so it's just a misunderstanding of how optics works, I think. We can use the Hubble Space Telescope, which, as you said, now, there's James Webb coming, but we had HST. We can see 100 billion, not 100 billion, but, billions of light years away. There's that galaxy. You can't point the telescope and then show the American flag on the moon, for example, and prove to the moon hoaxers that we landed on the moon. Doesn't work that way. That's not how optics works. So sometimes it's easier to see what's farther away than what's right under your own nose. And so it's not true that if there was another planet there, we would have seen it. Probably not, but I have seen articles, real scientific articles, not just popular press, that there may be another planet that could be very large, maybe Earth-sized or even bigger, lurking in the Kuiper Belt, and it's possible. It's not probable. So the comment was right. It's not probable, but it's not impossible.
Wow, interesting. While I have everyone's attention, I just wanted to say, well, we're running out of time to take calls. We got about 5 minutes left, but next week we have for guests. I usually announce this at the very end, but I just wanted to do it now. case someone drops off. We have Tom Carey and Don Schmidt. They're going to be talking about their new book. And at the very end, for fun, only a half hour left in the show, I'm going to be actually interviewing two people from, this is for fun now. It's just for fun. And it's called, it's a movie coming out, Elvis from Outer Space Conspiracy. And there's an Elvis impersonator, like I said, and this is for fun. And also Tracy Woolshard, who's the writer-director. So that is for fun. It's my birthday next Tuesday, so I'm doing a little
happy
fun.
Birthday.
Yeah, in advance. Yeah, a little fun at the end of the show. Anyway, so moving on. I think we're about out of time for calls, unless if someone wants to get a quick call in, we can take one more call. That number's up on your screen. It's 855-472-5483. Otherwise,
don't forget
actually. Go ahead.
Don't forget in Men in Black, Tommy Lee Jones told Will Smith, Elvis didn't die, he just went home. Remember that line? He's an alien. He went home. Yeah.
Yeah, that's right. So did we actually discuss the total idea of how, like, any craft can use dark matter to create the 0 point energy? Did you go through that whole thing? We only have a couple minutes left, but
we never got there, so we should get there. Yeah, so no, but remember, the 0 point energy is dark energy, not dark matter. They're probably not related, but your question is very good question, because I said this a few weeks ago at the SCU. So even though dark matter interacts very rarely, and dark energy, we're not sure what it is, it's probably related to 0 point energy. The point I was making about propulsion was that if we could find a way to tap, if there was something we can't imagine right now today, to tap into dark matter and or dark energy, we have this giant fuel source then, right? You don't need fuel anymore if 70% of the universe is dark energy and 25% is dark matter. Then if there was some way to tap into that, maybe that could allow for propulsion, for craft, without needing to carry fuel. And this would not break laws of physics. It's not propellantless propulsion, which is a term that's out there. It wouldn't be. You're just using the natural fuel, the natural propellant of the cosmos. I don't know how that would work, because we don't know what dark matter is yet. We don't know what dark energy is yet. But what I find compelling is there's 95% of the universe out there we don't understand. 95%. If there was some way to tap into that natural background of the universe that's all around there, the dark matter and / or the dark energy, I feel like that's untapped potential for propulsion that doesn't require you to take all this fuel from your home base.
Right. People have talked for years about, let's see, I want to say helium-3 on the moon. Could be used for energy and like to create some type of base there and actually launch from there. But can that actually be used for fuel, helium-3?
Yes, and actually moon is a great place because it has less gravity. So right, the idea behind moon base is similar to, like it's like having a sky elevator, that once you invest in getting somewhere, then the next step is easier. So if we were to go to the moon and we mined helium-3, we have a bonus of also the moon's lower gravitational field. So now it's easier to go places, right? So I wish that, a lot of these ideas, like you just mentioned, helium-3 and the moon, we were supposed to have done that already in like 1995, right? If you watch The Twilight Zone, we should already have been on the moon. We should already have a base.
And flying cars. Don't forget flying cars. Yeah.
Oh, God, I want my flying car. We're 5 years late, right? At least Back to the Future 2015. Yeah.
I'm trying to think who it is. His father was involved his grandfather was involved in Roswell. And why can't I think of his name? His father was wonderful, passed away a few years ago. Someone's going to crown me for forgetting his name, but he's working on the flying cars. He's actually got like a scooter and everything else out there. He's getting funding for. I'll think of his name afterwards. It's terrible.
But the problem is not the technology. We have the technology for years. It's people. Three-dimensional travel. We would crash into each other. I don't care. I want my flying car. I'll be honest with you. As great as the internet is, allowing us like have this interview, I would rather live in a world with a moon base. And I know a lot of viewers will get angry at me. I apologize. I would rather have a moon base and flying cars than the internet and YouTube. I'm sorry.
Wow.
As great as they are, I would
think that's
rather
wonderful,
have a
but-
moon base.
Yeah, we're
Yeah.
right at the end, Matthew. Thank you so much.
All
All right. All right, everyone, hang in there. And well, I should say hang in there. We'll see you next week. And remember to keep your eyes to the sky. Thank you very much.